SAR ADC, DAC R2R ladder, sample and hold circuit, and ADC comparator. In this phase, the ladder, sample and hold circuit comparator set up using simulating devices like rocker switches for the DAC and a potentiometer and a logic sample and hold button for the sample and hold circuit. So we're getting around 5.16, 5.17 volts. And now let's see what the voltage is on this chip. So we should, this is just some random number. Okay, so we're getting around negative 0.88 volts. So once I press this PBNO, the voltage from the potentiometer should match around the voltage of that is present over here. So let's quickly go ahead and do that. Cool. So now if we were to check the voltage here, before it was negative something, negative 0.8. Now we can see it's around 5.09, 5.8, much. There may be some offset, but it's around that range. So now, so that's what this part is. And now I'm also going to talk about the DAC here. So let's first, so once we know the voltage that we get from here, what the DAC is supposed to do is it essentially matches that voltage. So this switches here such so that we can manually do the approximation. How it works is the first switch, it has it displays 2.5 volts. Next one is half of that, and it keeps going further and further. Altogether, it should equal to 5 volts. And so through that, because this potentiometer is from 0 to 5 volts, the goal is that once that is displayed here, then we're going to try to match. Later on, we're going to be using different logic gates, but right now I have this. We're going to be able to match that. It will be automatically matching such that this voltage that we get here is the same. The sample and hold circuit is responsible for capturing and storing an analog voltage temporarily. It works by latching the input voltage and holding it constant for a while. When the sample and hold button is pressed, the voltage is read from the potentiometer, which can change the voltage level. The comparator compares the output of the DAC with the voltage stored in the sample and hold circuit. The output of the comparator indicates whether the DAC voltage is greater than, less than, or equal to the sample and hold voltage. The comparator's output is used to control the SAR, which iteratively adjusts the DAC output based on the comparison, narrowing down the gap between the DAC output and the sample and hold voltage. The DAC built using an R2R resistor ladder converts the digital value from the SAR ADC into a corresponding analog voltage. The R2R ladder provides a simple and effective way to generate the necessary analog voltages from digital inputs. It works by using two different resistor values, R and 2R, to create a binary weighted output that corresponds to the input value. Thanks for watching.